All right. Hi. Hello, everyone. Today I'm just gonna be building, some um, features of our application. So remember, we have a protocol to build, and today I'm gonna be working on the socket, right? So just to give, maybe there's someone out there that's trying to follow along, see what I'm trying to do. So how do I make this full screen? Let's see. All right. I'm just, I don't think I know how to do this. All right, so let's just minimize this. We'll come back to this. Yeah. All right. So a socket, right? I'm trying to implement a socket. So what's a socket? A socket is basically, let's say you have um let me change my canvas. So let's say you have a secret world. Okay. So you have um bunch of stuff doing things, bunch of services. So this is service one, this is service two, service three, right? So your socket is your portal that enables you to access this underworld. So I can call this, let me say, um, user space, right? So let me call this user space, okay? And then I can call this um, kind of like an underworld or like the application space. So this user space is trying to make use of this application or make use of these services, but you don't want to kind of bog the user down with the details, right? So what you do is you create a socket. So your socket sits in between and basically is in charge of calling the services that might be required. Okay, so you call this service, call that service, and it's going to call that other service. So maybe this is like a send, this is like a receive in the context of what we're talking about, right? And then this would be like a listen, or yeah. So you you don't want to know, or when I say you, I mean the user doesn't want to know the details of how all these are implemented. You just want to kind of do that. So your socket, right, is is your guy, is basically the person that's trying to um, allow you interface with the application level or the application layer, however you want to think about it. So yeah, so this is what we're going to be building. Um, to be more realistic, uh, I wanted to pick the eraser. Okay, so to be more realistic, your socket is going to interface with something called the uh, in more formal terms, it's called the PCB. Now, not a printed circuit board, like it's called the protocol control block. So the protocol control block is basically what identifies each you could say connection, right? So let's say, or basically like any transaction that is going on. The Let me just, I'm trying to make this uniform. So let's just pick this. All right, let me pick this also. I want to duplicate this. Okay, how do I do that? All right, I'm struggling with this. Undo, 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 undo. Control Z, Control Z, Control Z. Yeah, duplicate. Okay, so you have an application, right? And it's or rather, yeah, you have an application. Now these PCBs, okay, as it's being called, they are basically um like I said, they are protocol uh control control block. Okay, so these are the things that help to keep kind of like meta information about any connection. So in a in the real world, or no, not in the real world, but like in the kernel, you'd have a socket, right? And then because the networking stack is implemented in the kernel space, as a user you don't have access to this. So the socket is basically going to help you navigate by sending particular requests, okay, and then the particular maybe protocol you're using. Let's say you're using a TCP, for example. Let's use TCP. So in TCP, right, what you're going to do is this will be labeled a TCP PCB. Okay, so it will be labeled to be a TCP um, protocol control block. Now, TCP, usually um, there's also one for how's it called now? There's also one for uh let's see, for the internet protocol. That's the IP, right? So you're also going to have one for IP, and the one for IP is basically going to have information. So what kind of information does the PCB hold? It holds information like your uh, like the foreign address, that's the destination address that this socket is kind of bound to, and the local address also. So like the socket's own address also port information, things like state information, like what particular state, especially if it's a connection oriented protocol, stuff like that. So yeah, that's a lot of talk already. I would like to just get started. So this is basically what we are focusing on, this socket protocol or this socket interface. Yeah, so I think that's all. So I can go into the, so like I said in the previous video, I would be using um kind of, the book is not just like to um see code and stuff like that. It's basically like to help me see what I need to implement, right? So like some of the things that, so even though I know some of the things I need to implement, I might not remember them all as it will be in this book. And there are a lot of open source maybe distributions or even networking stacks out there, but they would help you like navigate as a book would. So that's why I decided to stick with the book. So for example, you have your socket system call. Okay, so this socket system call, it's in Linux or in the Unix world. System calls are basically your portal or your entry point to the kernel. So it's basically how you submit um, work for the kernel to do. So because like basically you don't have the right to do some certain things, so you kind of make requests to the kernel to help you do those things. So how do you do this? So the socket create, right? So yeah, so I was saying that the socket system call is going to create a socket, obviously. So the socket creates is going to call the SO create function. So this is the function I'm trying to implement, right? So um basically, it says most system calls are divided into at least two functions in the same way the socket and the SO create are. The first function receives the from retrieves from the processes all the data required, calls the second SO dash dash function to do the work, and then returns any result to the process. Okay, so yeah. All right. Let's see. Okay, so looking at this function, right? So what is it trying to do? It's basically um takes four parameters. One is the domain, the second is this, the socket um um reference, the third is the type of socket, and then the last is the protocol. So yeah, so it basically calls pf find protocol, which is basically to find the protocol from the domain. So this is much more complicated, right? Because this is actually like the actual implementation of TCP, and so basically what it does is that it checks, their address families. So you have like your OSI family, your Unix family, your TCP IP family, that's the IP, or the INET family. So it finds the protocol under that particular family. So it takes the domain. This domain is like a point, is like a yeah. So the domain is basically a family of protocols that are related together, right? So it finds the protocol, defines the type, but we won't be doing all this. All we just need to do, right, is to instantiate a new PCB for um our socket, and then connect our PCB to that socket. Okay, so I will do that in this function here called create. So what are the parameters? I'll be taking in the sorry, just a minute here. Ah, right. Okay, so um so let's say already there's a type. Okay, so let me just put a type. So and a let me see. Photo. Also, I really don't think this is necessary, but just for completeness sake, I will just kind of add it here. So um now, yeah, so like I said, what are we trying to do? We will basically just create a new PCB for this socket, and then next thing we do, we connect the PCB to the socket. So what that means is that, so back to our diagram here. So what that means is that you're going to have a socket bound to a specific PCB. So let me say you're going to have double pointers. One pointer pointing here, another pointer pointing here. So that from the PCB, so data can come from top, and data can also come from the um let's see, so from the bottom. So basically this is like incoming, oh sorry, outgoing data, this is incoming data. So when data hits a PCB, you want to locate the particular socket is related to, so that you'll be able to forward it to the user, the particular user. And when data is going out in the outward direction, you want to be able to locate the PCB that is connected to. So that's why you need like double pointers to be able to do that. And then let's see. Okay. Okay. So yeah. So those are the things you need. And to be able to do that, let's see. I think we already have. Okay, so a PCB. Do I have my PCB functions? Yeah. So I think I need to split this because I need to be making reference. All right. So, all right. So what I need to call, right? I need to call the allocate function. So these functions don't have an implementation yet, but they would soon. So PCB allocate, right? So this is going to create a new PCB, because since this is a new socket, it's most likely won't have a PCB associated with it, right? So we want to create a new PCB for it. And then after you've done that, so you would, is there an attach? Something like an attach here. Let's see, attach. Okay, there's no attach. So uh, I don't think connect is the right word. So let's use attach the PCB, the newly created PCB to the circuit, right? So this is basically how you're going to kind of, so I think I should create the function for that. So PCB allocate, okay, PCB detach, PCB connect, or is that the function? I'm not sure. All right, so let's just do that. Um, all right, so um, yeah, so let's just call PCB connect function. So now what we've just done is, once we are creating a socket, we allocate a new, what's it called now, a new PCB, right? And then we connect the PCB to the socket. So we most likely need a socket reference, right? So that's like a socket handle. how do we do that? Or okay, so that also means we need a um so we need to create a new socket actually. So create, let's see. I have a socket class. Okay, so this is supposed to represent my socket. So what I do here is I basically so let's use a pointer, right? So we would basically create a new object, a new socket object, right? And initialize its, let's see, its parameters. So like the type, the options, the state, the PCB that it's connected to, stuff like that. All right, so let's see. Okay, so but I think with the way it works is this. So let's see, is this let's see, is it this class? No, 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 not this class. What's the name of the class? Crypto, yeah, crypto core entry. Yeah. So here, the way it works is I'm supposed to process. It's supposed to come in as a request, right? So let's say the user wants to, you know, about attach a new socket. Yeah. So I have this. So I'm not supposed to be the one to attach it myself. I'm not supposed to call this function myself. So I'm supposed to send a user request, right? So what I do is I call, um, I submit a request to a request queue, right? So I have a request queue here. So this queue called a request queue is being processed. So basically, how I would approach that is I'm going to, hmm, so basically what you do, right, is let's say so I'm trying to create, so first of all, before we even do this, let's, let's see, let's create a new socket. So, uh, so, so, use socket. All right. So then I'm going to call it USOC. And then, all right. So I'm still going to initialize this. I'm coming. So basically, I have this socket object here. Um, so after I've done this, right? I also, so let's just check our reference book. So basically, it's ASIO creates. Oh, it already takes in a socket pointer. So what creates a socket pointer? So let's see when ASIO creates is called here. Okay, so SO socket. So it's struct socket SO. Okay, so it's just a normal, it's just like a pointer without that hasn't been allocated, right? Yeah. So I believe this is where it's getting its value from. So let's check out this struct. So ASO, yeah, ASO. So ASO. So this is SO, makes an allocation for SO, right? So this is like a new call, and then we zero it, set the type, set the ID. No, uh, set the protocol, and execute the user request of the protocol. Okay, yeah, yeah, and then we allocate it or we assign it to this. Yeah, Does that make sense? So basically, what I just read there is that you have um so basically you're going to have create a new socket, right? And then after you've done that, you set the parameters that you would like to set. So but we need a let's say a global, well, not necessarily a global variable, but the owner of this request queue is the protocol. Okay. So let me just create um let's see let's see. Okay, so I'm going to have a class, right? And then this is going to be the protocol. And then the protocol is basically going to have um mm, is basically going to have let's see, is basically going to own a queue. Okay, let's just make this a struct for now. Okay, so we would have a queue, right? So let's say request queue. Um, pointer. We need the pointer to to a queue, and this will be the queue of our requests. So let's just move this. Let's move this. Let's just make a type there from this. Um, let's see. Yeah, I know. Yeah, we also need to create new buffers for it. So each socket is going to have. So um let's see. So make this go away. Alright, so I think I should just move this to a new I could also do this. Yeah, that's fine. Let me just make this full screen also. Yeah, yeah, I think that's fine. So every socket, right, is going to have two buffers. Um, each uh, so this is the user space buffers. Okay, so let's say let's call this one the transmission buffer. All right, and let's call this one the receiving buffer. So these are the buffers that data would be fed into. So the sockets also needs to have pointers to these buffers. Right. So so yeah. So that when the PCB is putting the data that it received, so when we're going this way, it will go. So data would go this way. No. So your data will go this way into the PCB, into the socket, and stored here. Okay. And then data would come this way into the TX, to the socket, to the PCB, to the destination. Yeah, so that's the plan. So let's get rid of this. Yeah. So, all right. So right now so at what point do we create this? So once a new so where is my socket? So once a new socket, oh okay, that's fine. So we should have a default size for the buffers. So means both TX both length and sorry and RX both length. All right, so we can then initialize the so that's why it's complaining that we need to initialize those yeah, and also this receive with the RX both length. All right, so let's see how the error. Oh, let's see. Let's just move this bit to the side because we are actually not using this at the moment. So we just get rid of that. So we have our socket, right? So socket initializes our buffer. So immediately a socket is created, the buffers are also initialized. So where so yeah, so these two buffers are initialized as soon as the socket has been created. Yeah, so once we create a new socket, right? So we create a new socket, and then we also create a bunch of arguments that we're going to this let's see so the PCB is of type what? So let's see. Okay, I think this is where we have to basically UPCB UPCB let's see. Okay, okay, I have a struct for that, so this should not be void. I usually use void for when I'm not sure of what to do yet. So I'm not sure if that's a good idea, but that works for me. So let's see. So struct UPCB. do we need? Okay. So struct two PCB, right? So we're pointing. So this will hold the pointer to our PCB, and then these are our buffers, and then also we need to set the states. Okay. So I think I have to use like an enum class for the state. So I have something like that. So I don't need to reinvent the wheel. So let's do where do I have that? States. Where do I have my states? Let's see. Hmm, I'm not quite sure where the state is. Uh, we split data factory. Alright. Yeah, this is what I was looking for. So let's just yank that. Let's just put it here. Definitely, I'm still going to have to get rid of that because I don't want to duplicate it in both places. But I just wanted to have the states with me, and they are short here. Okay, so let's see, states. Yeah, so let's keep the socket open. Okay, uh, so let's keep the socket open. Let's see, where's the args? Where are the args? All right, so mm, yes, it's right. So let's just give it a state code of open. Okay, and I think that's supposed to give me an error because that's not. Yeah, so probably I need to cast it. And this is the issue I have with classes. If anyone has a solution to that, just you can just inform me. So a better way to convert. I could use the raw enums, but they are not um encouraged. So I'm just trying to play safe here. Usually, I still try to use what's best for me, what makes my life easy. But sometimes you just have to try and obey the rules. Okay, so so I have my args. So which other argument do I need to set here? Hmm. So I don't think. Okay, yeah. So the pointers to the. Okay, but I already have that. I already have that in the SO. So PCB. Sure. Yes. PCB. PCB. Ah, okay, so we have socket create. So we do. So we've created our socket. We initialize our variables, and then we submit. We submit this. So this guy should be able to take use sock the the yeah, yeah as a parameter and also the arguments. So PCB args dot get also. Right, so it will be able to have access to those. Let's see. So this is a pointer to aka arg star. Yeah, that's what I mean. And then this is also aka socket star. Yeah. All right, so we have this. We've submitted this, but I don't think so. Let's go to the definition of this guy. Let's see. Let's go to the definition of this guy. Oh, we already have that. Oh, excellent. So I thought we haven't specified it in the function prototype yet. So let's just see. So I have create my socket, right? I submit the request that I want to attach this socket to a particular PCB. Uh, and then this U attach. Let's see. Let's see. So I create alright, so let's see protocol entry. So you attach no no let's see. You attach so let's see. Okay, so when I call you attach here, I haven't implemented it. So when I have this, it should be able to call this function. So I don't know why I brought this here. So let's take it back. Sometimes you just move things around for no good reason. So this guy, right, attaches um UPCB to USocket to UPCB. Okay. So what I do here is I I have to kind of create a PCB if not exists yet, right? And then attach it to the socket by calling UPCB attach, right? So do I have an attach here? Why don't I have an attach? Allocate, deallocate, lookup. So let's use the allocate function for that. Since that sounds like really close to what we're trying to achieve. So let's use the allocate function for that. So we have the allocate function. So basically, all right. So 16. Um, uh, yeah. So let's change this to allocate. All right. So okay. So what's the next thing for us? So once we've submitted this, right? So I don't think that's what connect is for. So let's get rid of that. So we've created a new PCB for this socket. Oh, sorry. Now let's move this up here. So we created a new PCB for this socket, and we've attached the newly created PCB to the socket. I don't know if I should separate these two functions. So create and attach, allocate and attach, right? So let's do that. Let's just allocate and attach. So attach. Allocate creates a new one, and attach basically, as the name implies, attaches it to the socket. Um, yeah, something like that. Um, okay, so we've done this, but that means we need to submit another request again, which doesn't make sense for me because you can do the two in one. Okay, so okay, no, you don't need to do that. So we're already saying that the attach is basically calling those two functions. Okay, so after we've done that, so yeah, I think that's for. So we just need to do some error checking, check if so. Um, so I don't know why these are void. So let me just change them to integers. So um, error paste this. Uh, can I do this? Okay. Yes. Oh, sorry. Keep trying to learn some of my tricks. So, there, and paste. Also, I did need to record for that. So we just change. So, so they're going to be returning some like basic error codes. I think I have error codes handling somewhere. Somewhere. Error. Do I have that here? No. Let's try session. Error. Error. Code. Nope. Code. Nope. All right. So, yeah. So, but basically, these are supposed to be returning. So we need to just check if our socket is um if the socket, right, if the we need to check if there is a valid, first of all, check if the socket is valid and that there is an assigned PCB. Okay, so then we know that we're good to go, and then we can return attach the newly created. Let's see. All right, so I don't know, I keep doing that. Okay, okay. All right. So yeah, so the error handling is basically I need to be careful how I handle my errors. So this is basically how you implement something like this. So of course we are heavily modifying this. So the user request basically returns an error, and then if there was an error set, then we set some states on the socket. If the error was set, this is basically like, so I don't want to copy this too much, but like it gives me an idea of how to go about things, right? So yeah, so we'll be going ahead with others. So we have this was for create, and then for the attach, for example, the PCB allocation and stuff. Like I said, we haven't this layer. Okay. Let's see. So this layer have not been worked on yet. So this is the layer I'm working on. So kind of work on it, kind of top-down approach, right? So that's why you see some functions here haven't been implemented yet, and these are the ones I'm focusing on right now. So because they are making reference to this, I could just call them without the implementations yet. Then I would implement them later. So yeah, so that would be all, and I'll try to make them short to be kind of useful, but I could also make them longer also. So, all right, thank you.